Section 1. Let's say you want an AI agent to browse the web for you. Not just fetch a URL, actually navigate, click buttons, fill forms, extract data, the whole thing. The standard approach right now? You take a normal browser like Chrome, bolt on a Playwright or Puppeteer wrapper, and pray your agent can figure out how to simulate a human clicking through a visual interface that was never designed for machines. Agent Browser Protocol takes a completely different starting point. Instead of wrapping a human browser in automation glue, it builds the browser protocol itself from scratch with AI agents as the primary client. The browser becomes an API endpoint. Not a visual surface you're scraping. An actual structured interface that speaks the language machines prefer. In concrete terms, here's what that looks like. An AI agent sends a request, navigate to this URL. The protocol returns not a screenshot, not a raw HTML dump, but a structured, semantic representation of the page. Clickable elements come back with IDs, coordinates, roles, and context. Forms come back as typed schemas. The agent doesn't have to parse visual noise. It gets actionable data. The agent then issues commands: click element 42, fill field email with this value, scroll to section 3. The protocol executes those commands and returns updated state. It's a request-response loop. Clean. Deterministic. Designed for agents, not humans pretending to be agents. This is open source, available on GitHub, and the architecture is genuinely interesting for anyone building autonomous agents that need real web interaction without the fragility of simulating a human mouse. Section 2. Okay, honest time. This is a protocol project in active early development. That comes with real constraints you need to know about. First, this is not a drop-in replacement for Playwright or Selenium if you have existing automation scripts. The entire model is different. You're not scripting human actions anymore, you're designing agent-to-browser communication. Migrating existing automation code is non-trivial. Second, the structured page representation the protocol returns is only as good as the pages being parsed. Heavily JavaScript-rendered single-page applications, shadow DOM components, canvas-based interfaces, these are still genuinely hard problems. The protocol doesn't magically solve the complexity of the modern web. It gives agents better primitives to work with, but messy web pages are still messy. Third, authentication flows, CAPTCHAs, anti-bot measures, none of that is solved here. If a website actively fights automation, this protocol doesn't give you a bypass. It's a better interface, not a bypass. Fourth, this is early-stage open source. Production reliability, edge case handling, documentation, these are areas that need more community work. If you're building something that needs to run in production today at scale, you'll be contributing bug fixes as much as shipping features. And finally, browser rendering fidelity. This protocol is agent-first, which means it deprioritizes the visual rendering that human users care about. If your use case requires seeing what a human would see, this architecture isn't the right fit. Section 3. So where could this realistically go? A few concrete directions that follow directly from what the architecture already is. The most immediate useful extension is a standardized action schema, essentially a universal language for agent-to-browser commands that any AI framework could implement against. Right now every agent framework, LangChain, AutoGen, CrewAI has its own browser tool with its own abstraction. If this protocol becomes a shared standard, you get interoperability. Build one browser backend, connect any agent framework. Another realistic near-term development, tighter integration with tool calling in modern LLMs. Models like GPT-4o and Claude already support structured tool calls. A browser protocol that natively exposes its actions as tool definitions could let agents use web navigation as naturally as they use a calculator or a code interpreter today. That's not speculative, it's just connecting two existing pieces. Longer term, you could imagine this protocol becoming the foundation for sandboxed, auditable agent browsing. Because every interaction is a structured API call rather than simulated mouse movement, you get a complete, inspectable log of exactly what an agent did on the web. That's valuable for safety, debugging, and compliance in enterprise contexts. If you're deploying agents in production and need to understand what they did and why, this kind of architecture makes that tractable. Something worth noting: if you're hosting this kind of infrastructure yourself, DigitalOcean's managed services are actually a reasonable fit for running protocol servers without a full DevOps team. Section 4. So why does this exist? What's the actual problem? The problem is that the web was built for humans. Every browser ever shipped assumes a human is on the other end, someone with eyes, a mouse, patience for animations, and an intuitive understanding of visual hierarchy. When AI agents try to use the web, they're essentially wearing a costume. They pretend to be a human, they simulate mouse clicks, they screenshot pages and try to figure out what they're looking at. It's slow, it's brittle, and it breaks constantly when websites update their layouts. This isn't a theoretical complaint. Anyone who has built production systems with browser automation knows the maintenance burden is enormous. A website redesign can break months of automation work overnight. Screenshot-based agents burn massive amounts of vision model tokens just to answer the question, "What's on this page?" Agent Browser Protocol is built on the premise that agents deserve their own interface. Not a human interface with a robot strapped on top. A protocol designed for the actual client, a machine that wants structured data, deterministic responses, and clean action primitives. It's the same shift that happened when mobile apps stopped being just websites on a phone and became native apps designed for touch interfaces. The web for AI agents probably needs that same rethink. This project is an early, honest attempt at doing that rethink from first principles. Whether this specific implementation becomes the standard or not, the question it's asking is the right one. And that's worth paying attention to.